Good afternoon, everybody. Thank you for attending this event that is looking at conservation of Mediterranean ecosystems under climate change, challenges and adaptive solutions in the sea of fast warming and tropicalization. My name is Gil Rilov. I'm a scientist at the National Institute of Oceanography in Israel, which is part of the Israeli Oceanographic and Mineralogical Research. I'm also a faculty at the Haifa University at the School of Marine Sciences. And I'm also here representing Future Maris. It's a big European project that deals with biodiversity and climate change and nature-based solutions. We have a nice panel here of experts, of scientists, and stakeholders who will be discussing these issues today. The context here is climate change that leads to species distribution changes. If in the past species were nicely organized as tropical, temperate, and polar communities, with climate and each of them with its own species range, today with climate change, as the climate is warming, this distribution shift. At the warm edge of the distribution, species start to disappear, and tropical species start to move into more temperate zone, and temperate zone species move into polar regions. And on top of that, we have bioinvasions that mix it all up there, so bringing species across realms. This leads to a change in regional and global biodiversity, which brings a huge challenge to marine conservation, not only marine, obviously, because think about it. If you have a temperate region now, which is now a mixture of both resilient temperate species, well, the less resilient ones are gone, and new tropical species as a process of tropicalization, the question is, how and what do you protect? For example, if you want to put a marine reserve, some of the native species that you might want to preserve are no longer there. On the other hand, you have all these invaders, tropical invaders, that are present. So the big question is, what biodiversity could or should you aim to effectively preserve? We've tried to tackle this question in a couple of papers, kind of opinion papers. One of them was talking about adaptive conservation planning and what is needed for that. And what is clear is that we need good basic science to answer some of these questions and to adapt. The other one is called a fast-moving target, achieving marine conservation goals under shifting climate and policies. We also looked at the current programs of measures of the MSFD to see how they address climate change. And our conclusion is that many of them do not. And we also recommended flexible thinking what and how to preserve, especially with a focus on ecosystem functions in climate hotspots and looking for identifying climate refugia where native species should prevail because the climate is not changing there so much. So let's bring us closer to the Mediterranean. I'm sure all of you heard, and some of you actually felt, I felt it in walking in Rome in June at 40 degrees, which was unbearable. This huge heat wave that occurred this summer, affected many, many people. Most Europeans don't actually have air conditioning, so they find the creative ways to deal with the heat. This is one way. But more seriously, this brought to an excess of mortality of over 15% in some countries, which is expressed as about more than 50,000 people dead than normal for the year. And that's not only true for terrestrial areas. The marine environment heated up considerably. This is the anomaly above the norm for the Mediterranean during that summer. And you can see that most of the Mediterranean has heated up quite substantially, more so in the Western Mediterranean where this heat was occurring. But you can see also some areas that actually did not heat at all, which may be considered a climate refugia. In an amazing coincidence, this paper came out led by Joachim Garabou, who is the next speaker, where many scientists, among them myself, have described the increase in marine heat waves and mass mortalities caused by them, which included many, many species, including sponges, urchins, corals, and so on. And it is caused mostly because of the increase in the intensity and expanse of marine heat waves. The other thing that is happening in this region is that it is a hotspot, global hotspots of bioinvasions. You can see the rate of increase in a number of species in the Mediterranean over the past 3 and a bit decades. We're talking about more than 100 species per year, with the highest rates in the Eastern Mediterranean, over 100 in many cases per 5 years. So it's huge. This is coming from the MEDEC first report from a chapter on bioinvasion that I co-led. So this is quite alarming, and now it poses a huge challenge for marine conservation. The question we are asking is what and how to protect. Should we search for to protect a climate refugia, or on the contrary, climate hotspots? What can we safely restore? Where can we safely restore biodiversity under rapid climate change? So in hotspots where sensitive species may be disappearing, should we? Is it worthwhile to protect them at all? And how to restrain invaders that are mostly of tropical origin and may enjoy this warming? And finally, what realistic biodiversity descriptors can we use to measure success? So these are the things that I think we will be discussing today and are worth considering when you think about conservation. This is also a focus of a big European project, Future Mars, that I mentioned before, that is looking at the links between climate change, biodiversity, ecosystem services, and nature-based solutions. It's a big group of people from around the Europe, and including the Mediterranean, and is also looking at futures under different scenarios. And we have in the room today, also remotely, 3 speakers from Future Mars, scientists, myself, and then Carol Truly from the UK, and Joaquim Garabou, who's from Spain, who's online with us. So the plan is to talk about these different perspectives from the scientific point of view, and then as a panel we will discuss the role of science towards achieving biodiversity targets at 2030, and the links between science, decision makers, and stakeholders. And we have with us 3 panelists that are stakeholders from NGOs and from the UN bodies and so on. So I will start by introducing some issues or tales of horrors and hope, lessons from the Eastern Levantine Basin, the Israeli coast, the hottest hotspots of change in the Mediterranean. What you're seeing here is a vermetid reef. It's a unique habitat for this region. It's a biogenic habitat under threat from many different processes that are driven by climate change. I don't have time to get into that. But I think you all recognize that this area, which is the hottest anyway in the Mediterranean, is also the trailing edge of native species, which makes them very vulnerable to excess warming, which is happening quite rapidly in this area. We already warmed up by around 2 degrees in this region. And we also have hundreds of species invading, tropical species that invade from the Red Sea. And we have strong evidence now from about a decade of surveys and monitoring of multi-species collapses at this area, native biodiversity collapses in not only on reefs, but also in other benthic areas. We have evidence for domination of invaders in the systems. This is from fish troll surveys, and this is from rocky reefs. I'll give you a couple of examples. So this is, these are 3 species, very important ecologically. We have very little historical data. We have a little bit for this species. One is a species that builds those reefs, almost completely gone. A very important predator that is now gone. That's was my focus on my PhD. And sea urchins, very important ecologically, also mostly gone. On the other hand, this area gets between 60 to 100 species every 5 years. And when we look at specifically on rocky reefs, which is my pet ecosystem, when we count snails and bivalves there, 95 to 99% of them are actually non-indigenous species, alien species. You can hardly find any natives anymore. Out of the 350 or so macroalgae, 85 are invasive, and when you count fish on the reef, about 45% of them are aliens. Now, when we think about aliens, they are always considered a hazard worldwide. Here are two examples of really hazardous fish. For example, these two rabbit fish that are algae busters. They eat algae very rapidly, remove them. And then we have a fresh invader, the lionfish, that now is creating havoc in the Eastern Mediterranean. This has destroyed the reef in part of the Caribbean. But are all invaders evil, or some can be beneficial in the context of climate change? I'll come back to this in a second, to this question in a second, but I think I have already convinced you that the first take-home message is that the southeastern Mediterranean is a hotspot of change. It's going through a phase or even a regime shift, turning from a tropical, temperate Atlantic into a tropical Indo-Pacific ecosystem through extinctions of native species, invasions of tropical species, and this is driven mostly by climate change. And we are really moving into an alien world, and we need to deal with that. And we need to think about the implications for ecosystem functions, services, like a blue carbon, for example, which I'm going to focus on today. And I will bring a first perspective from algae. So these are very important ecologically. They are ecosystem engineers. They provide habitat for other species. They are food for many species, and they also can contribute to potential blue carbon production. And here's 5 seconds on blue carbon. It is a nature-based solution for reducing excess CO2 from the atmosphere, just like on land, where trees can absorb CO2. Macrophyte communities underwater can do the same thing, and now we assess that they can contribute significantly to reducing carbon. The threat, there are two major global threats to macroalgal forests: overgrazing by these invasive rabbitfish, and we have experimental data to show that. This is from Turkey and also from Israel using cages, and overheating as well. These are projections for the future from future mares for this region, from the Israeli coast, and we're talking about 4.5 degrees more than today at the end of the century. So if you think about August in the 70s, it was around 29 degrees. Now it is close to 32, and it might be 36 by the end of the century, which is bad news. I mean, urchins, we know, we've done experiments, they have been killed by warming, and this is probably a big threat to also many macrophytes. This is probably how the reefs look like 50 years ago. We don't have any evidence for that. Lush brown algae forests, including Cystosera. This one specifically is endemic only to Israel and Lebanon. But most of the reefs today look like this, barrens of turf. And this is mostly caused by these rabbitfish. You can see a totally grazed area until the area where a line here where they can move out of their shelter. From that on, you see a little bit of a forest. And but today, many of these turf areas are now covered by alien species. These are tropical. This is a tropical species, Indo-Pacific Galaxara, that is taking vast areas of the reef now. And this is a relatively newer invader from the Atlantic that is is becoming abundant on a reef in front of the Aoelar, for example. So the big question is, can alien tropical algae functionally compensate for the loss of the native algae due to overgrazing and alien fish warming? And we're focusing here on carbon uptake as a blue carbon solution. We have looked at other functions, and what we did was we compared this native Gongolaria to these two alien species. We compared the thermal sensitivity, seasonality, and annual carbon uptake budget, and to sum up years of data from in one slide, we found that the native species is much less resistant to warming. Its optimum temperature is around 25, while the two aliens are 31, so they're much more adapted to future warming. The native species is abundant only in the spring, while the aliens are year-round, so they're also only productive in the spring. And when we measured and calculated the annual carbon uptake, it is much higher for the aliens than the natives, which means that they suppress the annual carbon uptake, which means that the aliens can offset or restore the loss of blue carbon due to loss of native seaweeds. That's a big message. That's actually a positive message. One last slide is from a fish perspective. So this is using troll data for 30 years. We looked at we showed that fish community is shift with temperature rise using this index called community thermal index, and we showed that this index is correlating well with the change in years and also with temperatures. And when we compare species thermal preference to species abundance change, you find that 37% species, there's tropicalization of 37% and borealization, which is reduction in cold water species of 34%, which means that about 60% is more adapted to warming. Not all of these tropical species are problematic. This is a very commercial species. So the take home from here is that some alien invaders are commercially valuable and can compensate for the loss of valuable thermally sensitive native species. So take home message 3 is that what happens now in the Eastern Mediterranean, the Southeastern Mediterranean, will expand to the west and north in the next decades, and we'll need to deal with that. So thermally sensitive species will continue to disappear as we move west, and alien species will spread north and west within the coming years. So what I presented here is kind of the canary in the coal mine for what happened in the very near future, west and north. So take home message 3 is that we need a more realistic view of alien species at the age of climate change, maybe even a paradigm shift. We must study and understand the traits, functions, and services of significant alien species compared to natives in the context of climate change. With this information, will allow us to make educated decisions on how to deal with them as threats or potentially as rescuers in a fast-warming ocean. And finally, we need to develop more realistic descriptors for conservation success, for example, for the MSFD descriptors, in areas where communities are fast changing due to global stressors, like the Eastern Mediterranean. It's a more provocative question. Can we consider some alien species a nature-based solution in this kind of extreme situations, right? So this is obviously a product of a work of many, many people and quite a lot of generous funding. And we will discuss a lot of these questions further as we move on this event. Well, we'll leave this slide for later, and I'll give the stage now to Joaquim Garabu, who's speaking to us from Spain.
Now, good afternoon. Thank you very much, Gil. Maybe we could go directly to the discussion with this really deep presentation. So thank you, Gil, for this. And I take these minutes that you gave me to present some details on some of the issues that Gil already pointed. So, but I think that it's good to remind ourselves some key questions. The first one that I wanted to remind is why we should care about the Mediterranean and how this can be an example or a model to learn how we can deal with the climate crisis and other crises. In fact, the Mediterranean is considered a multiple hotspot, and already mentioned the biodiversity with almost 20% of the species, marine species, only with 1% of the ocean surface. The arrival of non-indigenous species, already mentioned by Gil, is a terrible hotspot here in the Mediterranean. And among others, because there are other hotspots, we have the climate change. If we focus on one of the main drivers of the climate change, because we have the pH, the acidification, the oxygenation, and sea level rise, but if we focus with probably the most obvious one that we are feeling already, which is clearly feeling, is the temperature. The Mediterranean is really warming really fast. It's the warming rates that we measured during these last years points out that it's warming between 3 to 5 times faster than the global average, so the global ocean. So this is really worrying. Of course, this warming is not happening everywhere at the same pace, but it's overall the Mediterranean is warming really, really fast. And one of the signs or the signals of this warming is the increase of the marine heat waves. And in this graph, you see the evolution of the marine heat waves in the Mediterranean Sea. And we can see the increase in the frequency and the extension of these marine heat waves and the intensity, these different colors of the marine heat waves. So this poses really a problem. And as Gil say, if nobody, I mean, mentioned the marine heat wave in the Mediterranean, this is a map from the Mediterranean and the number of marine heat waves days that occur in this summer 2022 that broke many records in the region, especially in the western and in the central Mediterranean. So still now here in Spain this week there were some politicians discussing, arguing about the climate change. So I think that I mean this is another proof that this not true. I mean the climate change is there and it's hitting really hard in our beloved sea. What are the consequences of this warming? Gil already pointed some of those. So the first one is the tropicalization. I'm not going to go into this, but I wanted to focus more on the mass mortality events, which is one of the issues that hits really deeply in the Mediterranean. We have been monitoring the marine habitats and the Mediterranean species like this one, the red gorgonian, emblematic species, a key species for the coralligenous habitats in the Mediterranean. And these species are characterized by really slow growth rates between the millimeters to centimeters per year. And they provide this for many years because they are really long-lived. They can live for 10, even 100 years. What happened with this species is that the same species is exactly the same. In this photo, you see exactly the same Gorgonian colony that we have been monitoring for the last 20 years that died this last summer, linked to the mass mortality. I linked to the marine heat wave that occurred in the Marseilles in the French coast, and of course, taking into account the life history traits of this species, this slow growth and this long longevity, these species are not adapted to this kind of events of massive or dramatic mortality. The problem is that this kind of mortalities usually not only affect this colony, they affect several colonies or even the populations, as shown in this on this photo. That all colonies that should be red, in fact, they are dead, and this so it means that affects the species. Not only one population, several populations, sometimes even along thousands of coastline. Not only one species, but we have been quantifying or getting information for more than 90 species affected from different groups like mollusks, sponges, calcareous algae, tunicates. So it makes that it's a general it's a general phenomena affecting many species. In general, these mass mortality events are affected by they are concomitant with the marine heat waves, and this sad part of the story is that the monitoring that we have been conducting in these habitats or in these populations that affected by the mass mortality events, they show release poor signs of recovery. So the impacts are really at long term. So we need solutions, and here it comes the marine protected. Let me just stop by why marine protected areas we identify it as a solutions for the climate change. The first one is that because marine protected areas that can promote the ecological resiliences, because the better conservation status in general it's associated with a better resistance and a better recovery capacity of the ecosystems. Around the marine protected areas, the socio-ecological ecosystems that they can promote adaptation and mitigation strategies. In the Mediterranean, especially in the Mediterranean, the marine protected areas attract many visitors to visit the areas. So there's a large potential to raise awareness on climate change and other environmental issues, and be a demonstration site. So they can be really a leverage for the societal change that we need to tackle the climate change. And implementing or adopting or tackling the climate change issues in the marine protected areas, that they can be really important to enhance the management effectiveness of the MPA. So these are the main reasons, and this is why probably you all know the 30 by 30 target for the conservation. And now the conservation of 30% of the ocean by 2030 is included in many international initiatives. Hopefully, is going to be adopted in the next biodiversity COP that is going to be held in a few weeks ahead. So this important to know, but the issues that we have a lot of work to do, because in the situation in the Mediterranean now is that we have 8% of area protected and less than 1% strictly protected. And remember that for the European countries, the target by 2030 is that 10% has to be strictly protected. So what we know is that this is uncertain how we are going to get there, but we know that the Mediterranean seas will keep warming, whatever we are doing. So we have to, this is a real important goal to take, to move fast and an efficient way to reach the conservation goals. So the good news that I bring to you is that thanks to the effort of these international projects, European programs like Future Mares, we're working in the Mediterranean to enhance at the level of networks, to enhance the effectiveness of marine protected area networks, improving, getting more knowledge on the reaction or the response of the species, and knowing how the marine protected areas we can place them in the context of different scenarios. And in the context, looking at more local level, we have been working in another project funded by the Interreg Med program with the MP Engaged, that we provide this harmonized approach to develop adaptation action plans to the climate change. So the question that we have now is in the Mediterranean, we have less than 10 marine protected areas that have implemented some measures to fight the climate change. And we have more than 1,300 MPAs in the Mediterranean. So how we are going to make this operational? So it's we wanted to propose this challenge, so 100 by 100 for 30 MPA for change. So by 2030, 100 MPAs should have, or we would like to have 100 MPAs having climate change adaptation plans. We could start from the SPAMI network promoted by the SPARAC, and from there cover the entire Mediterranean, and those MPAs could be the flagships to implement or to promote the adaptation to the climate change. And just my last comment here, I think that from the experience of the socio-political, environmental, ecological complexity that surrounds the Mediterranean, the lessons learned and all the initiatives that we are developing here could be an excellent model for other regional seas. Thank you very much.
Thanks, Kim, very much for this insightful presentation. Carol?
Good afternoon, everyone. Can you hear me? At the back, you can. Well, we've heard the challenges facing the Mediterranean system. I'll just go back one. Yeah. So my name's Carol Turley from Plymouth Marine Laboratory. I'm giving this talk for my colleague Anna Quiros, who can't be here this week, but she was here earlier on last week supporting ocean actions. So this is really about what science can do to help. We've heard that the Mediterranean is a very challenged ecosystem. It has high diversity of marine indigenous species, including many unique and protected populations. It also has a highly diversified fisheries, many of them small scale, that contribute to food security, livelihoods, cultural values. So really important to society. But the pressures, we've also heard about the pressures on the Mediterranean Sea. We've heard how it's warming, probably faster than any other ocean area of this scale. Interesting. Sorry about that. There's some timer on here that I didn't realize. And you can see that if we keep on burning fossil fuel at the same rate, the Mediterranean really is going to be a very, very different world for the species that live there. And we've heard about basically the extreme heat events in the Mediterranean. These are like measured by heat days above a certain amount. And you can see the bottom area just shows how many more heat days there are, with some being extremely excessive. This is really not good for indigenous species. On the bottom is a model that I put in here from an old EU program called MedSea, and this shows ocean acidification since pre-industrial times. So you can see it's not just warming, it's not just heat waves, but it's also acidification of the Mediterranean Sea. There's also overfishing is extensive. We've heard how a lot of the marine protected areas aren't protected. And so this really puts a huge problem on the spatial management of an ecosystem increasingly challenged. We've heard how this can impact the health, indeed result in the collapse of local populations, indigenous populations, and this can result in the loss of ecosystem function, like the reefs that Gilles mentioned, and of course that invasion of the species, which may be a good or a bad thing. I think the science is out on that. So there's going to be redistribution of species and loss of indigenous species in the Mediterranean. Now, the Future Mars program aims to provide socially and economically viable nature-based solutions supporting climate change, adaptation and mitigation, whilst safeguarding future biodiversity and ecosystem functions and maximizing the delivery of services. That's quite a challenge. And it's exploring 3 ways of doing this, with a focus on climate resilient design and blue carbon species. So there's the conservation approach, which is the active management of human activities to improve populations and ecosystem health in sites where they currently exist. So protecting what exists. Restoring what's being lost is the other one. So basically to improve the population health of species that were previously thriving but are thriving less well now. And there's also the inclusion of nature inclusive harvesting, using harvesting practices that limit impacts on the surrounding ecosystems and promotes sustainability and biodiversity. So the Future Mars approach is fourfold. Firstly, they're taking the state-of-the-art climate models and bringing them down to the regional scale. And then is actually understanding what the key gaps on the biological impacts are from both field and laboratory experiments. So we know how it's going to change in the future. We know how organisms are going to act, and then we put those together and we produce new state-of-the-art predictive capability for species of high conservation and or commercial value. And then we asked another question is whether nature-based climate resilient projections can be made, and using these new generation of fit-for-purpose ecosystem models to see if that works. Now, Future Mars only started 2 years ago during the pandemic. They have been working very hard, and these are just some emerging results. On the conservation front, it's being able to inform how new species respond to, how species respond to unfolding climate change. For example, the migration behavior captured in a new generation of species distribution models. These are with more realistic predictions of future distribution, and this is to help inform MPAs. So where are these species going to? Where do we put our MPAs in the future? Also, it's looking to make climate smart conservation networks. So the challenge is that we need to prioritize, as Jules said, marine areas for protection that represent. We have a challenge, and that is to prioritize marine areas for protection. But the Mediterranean is deep. It's 3D. And we're finding out that deep water is hugely important for species to get around and to migrate in. So, and add to that the future climate changing, we need to develop 4D models. And these models, the preliminary models, have identified important areas based on both biological and climatic criteria for priority when designing a 3D, three-dimensional, but climate smart, adding that 4D aspect, protected area network. And it also has highlighted, as I said, the importance of the deep sea zones in conservation targets for future marine biodiversity. And the third, I think it's the third example, is the results are showing that science can be really useful in identifying climate smart marine spatial planning. And the approach identified three sort of areas. Is the climate change refugia. This is where ecosystems remain within the boundaries of its present state. So science indicates that these ecosystems will be okay. There's climate change hotspots, where climate drives these ecosystems into a new state, inconsistent with each sector's present use distribution, in other ways the way it's being used by humans at the moment. And we saw that the Eastern Mediterranean is really a climate change hotspot at the moment. And the other thing that was identified is bright spots, or hope spots as people can call them. This is areas where oceanographic processes drive range expansion opportunities that may support sustainable growth in the medium term. In the medium term, if we also mitigate CO2 emissions. So this created the means to identify where MPAs may remain effective or thrive despite regional climate change, and it also identified areas for climate smart conservation of blue carbon habitats. So this is where science can help. These are the scientists doing it. There's a whole bunch of them, and it's from 15 nations and 33 partner institutes. And it only started during the pandemic, and it's got another 2 years to run. So my thanks to them. If you have further inquiries on this work, you can ask Anna Quirios, whose email was up there, or Gilles here. Thank you.
Thank you much. Thank you very much, Carol. So you heard a lot about Future Mars. You can ask more questions about it. We have 3 scientists from this project right here. I mean, one is virtually here, but still available, I think. So you have questions for him. We'll start our panel. We have in our panel Carole from MedPen. It's an NGO that gathers all the MPA managers in the Mediterranean. She'll explain more about it. We have Atef from SPARAC, it's a UN organization about circling around the MPAs and other conservation measures. And Professor Michael Scolius. He's the head of many things. One of them is a organization of 133 NGOs that deal with environmental, not only marine. And he's going to bring more of the NGO perspective for this panel. I think we have 2 very short speed presentations from 2 of you. And I think we can bring up Carole for your quick presentation on MedPen.
Thank you very much for having MedPen here. Well, MedPen stands for the Median Network of Marine Protected Area Managers. So it's all about organization dealing with the management of marine protected areas. It can be NGOs, it can be directly public bodies, so quite a diverse types of organization. So we heard from Joachim a bit earlier how marine protected area can definitely support resilience of marine ecosystems, how they constitute a nature-based solution. But I would go a bit further here, indicating that a condition for that is that those marine protected areas are first effectively managed, and secondly, they are well connected. And this is why networks comes into play here. It's very important for marine conservation to take into account ecological connectivity. To date, you can see with this map how is a network of marine protected area in the Mediterranean region. It covers only 8.4% of this sea, but you can see here as well the imbalance in terms of geography. Most of the MPAs are actually located in the northern part of the region, but there is as well another imbalance in terms of ecological or ecosystem representativeness, and this was a point touched by Carol. We need to have more pelagic and more benthic and in-depth deep sea protection. This is particularly important because already actually our network is impacted and heavily impacted by climate change. More than 90% of protected area in the regions have been assessed as highly vulnerable under changing climatic conditions. We witness, and as has been explained earlier, mass mortality events, and the forecasts are quite daunting and even worrying because it's gonna be better. Actually, the trends are even more about an enhanced, I would say, hotspot for the region. So definitely climate change is an issue in terms of protecting our Mediterranean region. This is why the post-2020 MPA roadmap has highlighted as a key issue, both hand in hand, climate change and invasive alien species, and undialing stressing to take immediate action. To support decision making, Medpain has developed a policy paper with 7 key messages, among which climate change and supporting enabling marine resilience has been elaborated with articulated recommendation at all levels, from the very local to the national, the Mediterranean level, but as well the European and the international level. Because we do need regional and international cooperation. As you can see, the Mediterranean region is quite characterized by many dynamics, and its general condition has been characterized by a wide environmental and biological diversity across scale. This is why we do need to take into account all these currents, this active dynamic in terms of currentology, but as well in terms of ecological connectivity, because connectivity is definitely a determining factor for the survival and the migration of species, but as well the adaptation of potential population. So we need definitely to envision our marine conservation effort, but as well marine spatial planning in a network way. The MPAs have to be well connected in order to have resilient network of marine protected area. This is why we need to go beyond an approach of static protected area. We need to understand more and better what is the ecological continuum and how this continuum is evolving, changing across time because of climate change. So we have tools already, but we need to implement this. So this is why we do need science, we do need information, and we do need the scientific insight to deploy the right tools in order to help the regional MPA network to be more resilient. This through more eco-regionalization work or more modeling. We know very little about connectivity, and we know even less in terms of how this connectivity will evolve in time, in space, because of climate change impact. So we do need this scientific information to support a resilient MPA network in our region, so that this network can work at best and can definitely contribute to an effective 20 by 30 targets. So I'll stop here. Thank you.
So you're asking for us scientists to give you maps of connectivity and models for the future connectivity. It's a huge task, obviously, but yeah, I mean, within Future Mars, this is part of the task is to look at connectivity also in the Mediterranean, kind of limited based on some oceanographic modeling and genetics as well. So maybe we'll have some interesting products for you in the next 2 years. Let's give the floor to Michael here, who's going to talk more on the invasive species, but try to be short, 3 minutes, okay? So we have some room for discussion.
Thank you. Actually, what I'm going to show you, I'm a professor of environmental and marine chemistry, actually the first teaching of oceanography in my country. But here, as it was said, I will present also the views of MIO and the biosphere reserve that we have established recently in the area of southern Crete. Well, what we see here is that among the different alien species, this particular species, Lagocephalus scleratus, is becoming a real problem in the area, a real problem for the fishermen. You can see that from this catch, there were only 2 fishes that were not Lagocephalus, and these are dangerous for consumption, and they are in a protected area. So in fact, this backfires a little bit the argument that through protected areas, you can avoid major catastrophes. Of course, we support the idea of expanding protected areas and everything like that, but it creates a real issue of climate justice, not in the south, in Africa, but within Europe. Within Europe, this community actually is totally destroyed. And we have to see how we can deal with that. There are not yet methods. I don't know, yes. There are very many empirical methods, but for these methods, again, scientists cannot suggest with safety some of them, like selective fishing, or having more artificial reefs in the area in order to support the existing, the non-invasive species. So I just wanted to raise this as a major problem that goes beyond the ability of the scientific community at this moment to provide solution for politicians and for the society. I stop here. I think I used the minimum time and the minimum slides. Thank you. I don't have time to discuss about MIO, but it covers many areas, NGOs, but working closely with academia, and even publishing in the peer-reviewed articles together with scientists.
Thanks, Michael. You have presented a problem with very difficult solutions. I'm not sure if there's any. Certainly, I mean, like I said before, we have invasive species that are really invasive and problematic with no easy solutions. Some of these invasive species you can actually eat, like lionfish or rabbitfish, but these guys are poisonous and people died from them, so we need to seek for other solutions because harvesting for food is not a solution. They do have a very important poison that could be used if we manage to yeah. Yeah, but also if we can somehow harvest this poison, then maybe there will be motivation to fish them out or at least control their populations. Okay, so thank you very much. We have about 8 minutes for further discussion. So I want to ask Atef from Sparak, what's your comments about what you've heard so far, and what are what would Sparak take from this, and what do we need from us scientists to help you manage MPAs in the Mediterranean?
Okay, thank you. I will try to be more optimistic. It's not so dark. I mean, I'm working with the intergovernmental organization that deal mostly with the with countries that are bordering the Mediterranean, and we are the Mediterranean has let's say a particularity that there's a legal framework, which is the Barcelona Convention, that is since 76 signed and ratified by most of the Mediterranean country, and deals with the protection of the Mediterranean Sea. And there is a specific protocol that most of the countries are party to, which is called the Special Protected Area Protocol and Biological Diversity, that entered into force in 1998. It's an, let's say, as much as I work with this protocol, is such an innovative tool. I mean, it was amended in 95. When we start to talk about invasion in the early 19, we had the provision already included in the protocol. When we start also to talk about the protection in the high sea, the protocol have provision that enable country to also protect the high sea. But this is not only the only way, because the protocol is, let's say, legally binding, and the country have obligation to fulfill their obligation under this protocol. There is also a lot of strategic documents that were adopted recently. The first is what we call the Strategic Action Program, and there is a specific target that was adopted concerning climate change, and the country are have the obligation to start implement short and medium-term measure for climate change mitigation and adaptation, particularly warming, acidification, and contributing to disaster risk reduction through reducing emission, nature-based solution, ecosystem-based approach, and restoring as appropriate, ensuring resilience and minimizing any negative impact on biodiversity, thereby also contribute to halt global warming and acidification. And when we talk about nature-based solution and based on the roadmap that was what we prepared together with Medpan, there's what we call the post-regional strategy for marine and coastal protected area and other effective area-based conservation measure in the Mediterranean. And we have already adopted the 30 by 30 target that will be confirmed by CBD during this year, I think. You talked about the lot about invasive species. The Mediterranean also, we are now updating the regional strategy, what we call the action plan for the species introduction and invasive species. It was adopted, the first one, it was adopted in 2003. It's a sort of regional strategy that coordinates the effort of all the Mediterranean countries to address the issue of invasive species. And we start, for example, by building capacity of Mediterranean country. We elaborated a lot of guidelines to help the country to address the issue of invasive species. For example, how to control pathways and so on. And the action plan is now under the, let's say, adaptation for the 5 year. And it is based on a whole work done, because you mentioned a lot of marine strategy framework, but the Mediterranean have also its ecosystem approach and a sort of integrated monitoring program that enable all the country to do their national monitoring of biodiversity in coordinated manner in order to have a regional strategy. For example, to adjust more the new marine protected area, or to propose new and innovative conservation measure.
It sounds like a lot, but if you look 5 days from 5 years from now, what would be the most effective things to do in the face of warming and invasions? You think what needs to happen, or what do you need from the scientists, and what needs to happen at the national level, you think?
So the first thing would be that we need in the Mediterranean long time series of data, and also to continue monitoring in order to understand well the biodiversity of the Mediterranean. We have a lot of lack, and we have to have a continuous monitoring of the situation to allow us to be adaptive.
And we certainly have regions which are lacking tremendously with monitoring, and for example, the North African countries. I'm guessing that there needs to be strengthening the capacity of these countries to monitor and to protect.
Yeah.
Yeah. What is SPARAC doing in that direction then?
What?
Is SPARAC trying to promote this kind of
yeah,
action?
yeah.
Okay.
One of let's say 1/3 of our budget goes on capacity building and assisting the Mediterranean country to fulfill their job.
Thank you very much. I feel like we only just started this discussion. It's probably it requires a whole week workshop to start thinking about more deeply about these solutions. And I hope that we can continue this discussion in other venues. And I want to thank you a lot for this very short, very effective event. And thank you, Krim, for speaking to us from Spain. Sorry you're not with us. I want to thank everybody here for coming. And let's keep the discussion going.